So next up is Sri Chandra. He is a senior director from our platinum sponsor, IEEE Standards Association. So Sri will talk about what he does as part of the IEEE Standards Association. But prior to joining IEEE, Sri was associated with Freescale Semiconductors for almost 18 years, managing a global R&D team. He holds a bachelor degree in physics from Madras University and a PG from Indian Institute of Science. Thank you, Sri, for being the generous sponsor and for your 15 minutes talk. Thank you.
Everything is good? Do you want to stretch a bit? Can people get up? Stretch a bit, right? Can everybody get up in the auditorium, please? Yeah. So, stretch a bit. It's very cold here, at least for me. I don't know whether others find it cold. Maybe the organizer should put it a bit warmer. Otherwise people will go to sleep. So, thank you all. Appreciate it. First of all, I thank the organizing committee for giving us an opportunity to be here and sponsor this. In a way, it is our event, but from a Standards Association perspective, it's an opportunity to come and talk about some of the work we are doing. It's a good segue from the previous talk. I think one of the questions he kind of concluded that there are no standards and regulations in the space. So that's what we are trying to address. It's a new area for everybody. And of course, we get into this philosophical debate. Is standards too, will it stifle innovation if it is done too early, right? So I think there are aspects that we can do to get around that, and I will talk about it a little bit, okay? So Raghu did introduce me. So I am the IoT and infrastructure practice lead at the IEEE Standards Association. So anything that falls in this big space of IoT infrastructure. When we talk about infrastructure, we are talking about things like blockchain, or the horizontals, like AI is becoming a big horizontal. So I look at some of these areas, not just within India, but globally. So, we are sponsoring, so a couple of slides on IEEE Standards Association. I think it's useful. Anybody in this room, have you had a chance to contribute to a standard, use a standard and in your code or in your development? Raise of hands, please. Okay, so a couple of people, okay, super. So that's why we are here. So next time, hopefully when I come and talk here, there will be 2 more, I don't expect exponential increase in number, but we will go linear, okay? So we have 20,000 standards developers worldwide. We cut across various technology sectors. You can see that our bread and butter, our roots were from the Power and Energy Society, and then we moved to ICT and now everything under the sun, anything that touches upon engineering. In fact, I do not know how many people know this. There used to be a time when IEEE, to become an IEEE member, you needed to be an engineer, right? So that's no longer the case, And some people might think that IEEE has diluted its rule to increase its membership, but it's certainly not the case. If you look at even today's discussion, people are talking about medical stuff, A lot of people are getting into other areas or using technology today. In fact, I was working with one of our working group chaps in Philips, and when we as engineers think about a doctor, we think doctor of philosophy, PhD, right? And then that guy was actually a medical doctor running a working group in IEEE Standards Association. So I think things are getting into a different direction. If you look at our set of people that work on AI and ethics, the social impact of AI, we have engineers, but we are balancing the engineers with ethicists. People are trying to understand how these technologies are going to have a real impact in the world, and whether the impact is good or bad, and if it is bad, how do we manage that, because the impact is happening. I don't think we can stop that. We can manage some of these through standards and regulation, right? So, and the reason I put this particular chart today was for a particular context. I will talk about it in a minute. So, a lot of times, our core area used to be standards development. We bring a community together, develop standards, and then our product is the document, right? More and more we are seeing in the emerging space, it is becoming a little bit confusing. and a little bit complicated on what we should standardize, right? There are a lot of standards available. Do we have, a scope for another standard, If you ask standards developers, they will say that there is always scope for one more standard, right? So, but having said that, we wanted to make sure that not only people develop good standards, but they also get used, So from that perspective, we started looking at what we call as pre-standards. It is tried to understand what are the gaps that exists in the standardization world. Should we develop some kind of a white paper? Should we bring the community together who are thinking about similar problems? Solution may or may not be a standard at that point of time, right? So at least create these people with the similar thought process and see what needs to happen. And the other important thing that needs to happen today is what we call a standards implementation, right? So you have a standard. How do you ensure that products are complying to that particular standard? So IEEE has a program around conformity assessment, right? So the rest of the talk I have segmented in 3 parts, and it depends on the time Raghu gives me, Just raise your hand and I will just walk out, right? So, but I don't have too many slides. I have a couple of slides on one of the pre-standards work we are doing on NLP, right? And then during the break, there were a few people who were interested in clinical IoT and clinical data, security, privacy, and all that kind of stuff. And that is getting core into what we are talking about AI and perhaps a lot more into NLP. So I thought that I will share some of the work that is being done in one of the working groups. And then I have a couple of slide foils on what we are doing on AI and ethics. Just a caveat, I'm not a deep expert, so the other talks before me were deep technology, going with the conference deep text. So we are looking at, no, my talk is not deep text at all. So we have this industry connection program called Studies for Indian Language Resources, and we know that the next billion internet users will look at a lot of localization of languages. Already we are seeing web pages are looking at languages. I think one of the studies shows that the adoption of broadband within India will enormously increase if you have context and language-based web pages, not just in English. So the pre-standards work that we are trying to do, and this is being driven out of Bangalore, and that's why I encourage a lot of people to talk to Raghu or myself when we try to develop these things. This work is being done, chaired by Microsoft and in Bangalore, and they are looking at identification of use cases that could lead to proposal of standards. That is the main drive of an industry connection program. They cannot actually develop the standard itself, and the resources can be speech or language data or descriptions that can be essentially be provided as a machine readable form, right? And then the standards can also be done for localization of software. I think that's very critical when we are looking at different states, different languages. It is important that how we localize these things. This work is similar to some of the work that has already happened in European Language Resource Association, and also there is significant work that has happened in TDIL, and we are trying to leverage some of these activities and also bring them on into this particular activity that we are trying to develop. So the deliverables of this particular industry connection program, as I said, the industry connection program is a lightweight process for people to come together. It doesn't have the same process heaviness that a standards development has, is to identify the standards for each of these identified language resources. I think that's important. As we adopt more and more of this NLP, you need to have some kind of a platform or some kind of a framework, and then your applications can sit on top of that. We also want to collate a database with sample collateral for each of these language resources. And also, interestingly, we want to do some computer coding for some of these common use cases, that can be from an open source platform, so people can come and contribute to this source code. There are people already participating, and I just talked to CDAC here. I think hopefully they will be interested in this particular activity. We have identified others who are already agreed. We are hoping that the first meeting will be held in October 2019. Anybody who wants to participate, it is an entity-based activity. That means when you participate in this particular forum, you represent your entity, but there is no cost for participating actually. So one of the things I wanted to highlight here is the work that is being done on 2733. This is chaired by Dr. Florence Hudson. It is driven by our Engineering and Medicine and Biology Society. This is called Clinical Internet of Things, and it's on a framework called the TIPS framework. So there are some data that she shared, like the health data and medical IoT. In fact, there is a new term, I don't know, probably people are aware of it. It's called IOMT, Internet of Medical Things. People are looking at medical being the topmost use case, whether it be in the IoT space or whether it be in the AI space. There's a lot of adoption that is happening in this particular sector. And this is pretty significant, where it says 87% of health organizations plan to adopt IoT technology. That's extremely significant, right? So in this context, the precision medicine will leverage a lot of data. There is a lot of data already available. I was talking to Janaki here, and she was saying that she wants to do some research. There is volumes and volumes of data. How do you extract the data that you need? What kind of algorithms, what kind of software that you need to develop to kind of extract that. So there are many data sources: genomic, clinical, life sciences, environment data, connected health. Now how many people in this room are using a wearable device? The Fitbit, or at least there are one, two, yeah, there are a few raise of hands. Don't be shy, okay? When you ask these people, what is the time, they will press about 10 times, it shows everything except the time, right? So, so I've seen that, right? So in this context, TIPS is extremely important. There are key, when we talk about TIPS framework, it's trust, identity, protection, privacy, safety, and security. But what is important is we are always talking about, can humans have the right access to the right data? But we are going to live in a world where machines should also have these kind of platforms where you authorize a machine to look at a particular data or not authorize a machine, because I think it's a reflection of ourselves. They cannot have any accesses that is more than what we have. We have 2 more minutes left. Yeah, sure. So we had a similarly, 2733 is a standards working group. Before we did the 2733 standards, similar to what we are doing in NLP, we did a pre-standards working, a pre-standards activity. They developed a white paper. I don't know whether there is a link to it, but you can certainly look at clinical IoT IEEE white paper, and that's free for download. They published a white paper, why this is important. At one point of time, we were going to look at developing this platform under a blockchain technology, but we realized that blockchain will be one of those technologies that will be driving this. There can be other technologies, so we kind of segregated the technology and the problem we are trying to address, right? So this is the kind of the architectural framework. I won't go into the detail, but it looks at everything and anything that has to look at clinical IoT space, and what are all the different layers that are there. And distributed ledger technology is just one of the layers that are trying to drive this for some of the identity and privacy aspects. And now we have a standards working group that I think that has been going on for about 3 to 4 months. It's fairly new, but it's after IEEE 802. People know 802. This first meeting of this working group had about 230 participants. That kind of shows how people care about this data and how much interest is in this particular space. So I have a couple of last slides. I will wrap it up with here. So coming back to the AI work, I think there is a lot of interest on AI, but there is also significant interest on ethical aspects of AI. People are talking about fairness, bias, what is the ethics associated with it. So IEEE published a document. This document is available for free. It is called Ethically Aligned Design. How do you consider these kind of design aspects when you are developing your products? In fact, this published under Creative Commons, and there have been organizations who have adopted this. For example, IBM has adopted a version of Ethically Aligned Design for their engineers when they are talking about ethical aspects in developing products. There are 3 pillars to this, basically human values, but quite key is self-determination, but data agency. Who owns the data? We are living in a very complicated world. Where is the SLA lie? Who has the ownership of the data? And then the technical dependability that we are talking about. So this led to a series of standards, IEEE 7000 series of standards. There is algorithmic bias considerations. There is machine readable privacy terms. When we are downloading an app, the privacy terms are very complicated. Can we do it machine readable? Can I give preferences to my machine? And can it do a matchmaking and give me a subjective view of this is red or a green based on what it says and what I want, right? So very interesting work happening. I won't go through the details. And of course, all this is good when we have a certification platform. We are trying to see how we can, somebody talked about energy rating. Similarly, we want to say that is it AI safe for the products that are going to be developed. So there is a certification that is being developed around this. And that is my last slide. I hope it was reasonably useful, a tip of the iceberg view of what we are doing.
So we have one question that we can take. Anybody in the room?
Either it didn't make sense or I've been super clear. Either way, it's okay. Yes, it's an individual standard. Anybody can join, and you don't have to be an IEEE member to join. No worries. Yeah. So thank you, Kishore. All right.
Thanks
Thank
a
you
lot,
very
Sri,
much,
for
Raghu.
your time. A small
appreciate it.
moment of thanks.
No problem. Thank you. Thank you.
So next we get into the startup section of our talks. We have 2 talks lined up under this section. First up is possibly the man with the deepest pockets in the room. So Suri, as he is fondly called, he is a CTO of a venture capitalist firm called Idea Springs. So Suri has a master's degree in computer science from IIT Mumbai, and he started his career with Wipro quite some time back. He's having over 18 years of experience as a VC, as an entrepreneur. And as part of those 18 years, he has spent time, in addition to being an entrepreneur, also doing mentoring, advising, and of course, the investing roles. So over to you, Suri.
Oh, thank you. Good morning. Next, right? This is the next one, right? Okay. Good. So this is going to be a very light talk, okay? Like much of technology and all those things. And so here, if you see, like NLP is a lot of terms, a lot of things are happening in NLP. NLP basically is being a horizontal technology. It's actually cutting across businesses, domains. Like we see a lot of startups using NLP to solve problems. So in my talk, actually, I wanted to bring a couple of perspectives. One, actually, personal perspective, in the sense that, like, and maybe you can call historical perspective because I'm a bit old, right? Like, so I have seen products since like 90s. So I'll try to bring that, and then actually I will also talk about like how NLP is being used both in the front end and actually in the back end. So and also some of the use cases which we have seen, and I'll also like take a look at some end-to-end solution which some of our startups are working on. So let's start, okay. I don't know how many of you have even seen the top part of this screen. This was the first search engine, actually. So so this was in the 90s, we used to use this to even actually like figure out, like to search for information. So what it used to do is like basically like access FTP sites, get a list of files which are there, and then make it available for searching. So, but you have to tell whether you want substring or a lot of things, or it's a regular expression, things like that. So today I was actually thinking about it. Basically, like, so in the 90s, I moved to US, and my wife actually followed me 3 months later, and like she was new to cooking, right? So even to search for recipes, it was so tough. So take an example of simple Uppitu, right? If you say Uppitu, somebody says Karabat, somebody says something else, right? So, but the thing is, today you can just go to Google and say Uppitu, it will give you everything, Upma, Karabat, everything, right? So how is it possible? This is all because of NLP, right? Basically, like it finds out which are similar stuff, and actually like, so I feel search engine is one thing where NLP has played a very big role, whether it's in the front end or analyzing the data which is in the back end, right? So that's why I actually want to start off with this. Basically, like NLP is there since long time, and it actually maybe it has affected all of us, right? In that technology, when used in search engine, is really affected all of us, right? So today, because you can just go type whatever you want, you can type a sentence, right? Or you can even talk to it. It has made it so accessible. The information is so accessible. So that's one part, okay. So the other thing we have seen is that as an engineer, we were using CLI, like Unix CLI. That used to be the most intuitive user interface we had. Okay, so so then came GUI. Okay, so basically even personally, like when first I used to work on Unix and then went on to Windows. Windows was very tough to use for me because I was so used to actually CLI. So if you see CLI is like, you can say it's a command line interface, right? Basically like it's like chatting with the computer, but the problem with CLI was that you have to understand the commands and everything, right? So that actually, so it was easy for a developer kind of people to actually, or tech people to actually use computer, but not for end users. That's why the GUI came. But the thing is, what is the problem with GUI? I mean, like, some people will say, like, no, there's no problem with GUI if done properly. But the thing is, like, still there is a learning. You should know that, okay, this is what I should click, this is what I should do, things like that, right? If you actually see nowadays, actually, I'll tell you, like, a couple of weeks back, I was actually on the jury to select some of the startups for one of the accelerators. Out of 15 startups, about 7 of them were conversational UI. So that's CUI, okay? It's again like conversational UI in various domains and all those things, but people are getting there. But the thing is, if you see at this time, it makes it easier to use, but it's still not completely text-based, if you really see, right? There is really some buttons there. So people are trying to go back. So I feel that the world is going back to 90s. So that's another way, actually, like the conversational UI also uses a lot of NLP to understand what you're talking about or what you're chatting about, what is the question you're asking, how do I find the intent, things like that. So some of these places actually like conversational could be text-based or voice-based, right? We have seen startups in both areas. So these are all the front end, right? So let's try to see like what are the use cases or where are we, so we have seen about like 3,500 plus startups in the last 3.5 years. Lots of them, and actually like we have also invested in a couple of startups which use NLP. We don't call them NLP startups, we say they are solving a problem which uses NLP. And I'll try to cover some of them in my talk. So some of the interesting use cases is to understand customers, or how did a customer call went. Because like, was the customer happy? Because today, what do you do? What happens is that after the customer call is done, they will send you a link or something. You can say, I'm happy, 5-star, whatever. You can do that. But the thing is like, a lot of times people don't answer. And also that information is actually available in the call log, if you really analyze it. The problem with analyzing call logs is that there will be thousands and like 10,000 million calls which happen in enterprises, but there's no way you can actually manually go through each one of them and try to understand what happened. So that is one place where NLP or even voice analysis, voice to text and then analyze that, right? So those kind of startups actually are working on how do I take all this data and rate the call or rate the customer happiness, right? That's one space. We have invested in a startup called MeHoop, which actually works on this problem, right? So the other thing is actually there is another interesting startup, or a lot of startups are there. I'll talk about what I know, right? So this is very, very unique in the sense that there's a lot of technical documentation which is available, right? So the customer support, giving basically technical customer support, they have to anyway like understand all these things, and then they have to. So providing technical customer support requires a lot of understanding of the product, right? How it works, and what are the kind of problems which have happened before. And so usually like people think that it's very tough because like it requires real intelligence, right? Like I have solved some of these problems before, and that's why actually I'm able to correlate all these things and actually solve a given problem. That is another place where a lot of people are actually working on, in the sense that can I actually like use NLP to actually understand technical documentation, to understand how maybe an Intel processor works or a Cisco switch works and things like that. And also look at also look at the logs which are spewed out by all this equipment and things like that. And also look at the previous tickets which actually have come, and then people would have updated with, okay, this was the problem, this is why, this is how I solved it. Like human beings do that today, right? You're supposed to maintain a ticket and all those things. Can I combine all these things and build a virtual support agent? So people are doing this for frequently asked questions and all those things, but this is slightly higher level where you have to build a knowledge graph and put them together, and that's so we have a startup called Paratus which actually works in this space, okay. Then you might have seen a lot of news summarization startups like InShots and all those things. We have very less attention span nowadays, so we don't really want to go and read the newspaper. I still read newspaper, but a lot of you may not even like read newspaper, right? So, and the other thing in education is actually how do I take a book and summarize it for notes and all those things, or even to generate question and answers. So these are some of the things which actually like we were also trying to do in my startup, which was an education startup called Funtoad. So these are some of the areas where actually like NLP is used in the backend, okay? And there are a lot of startups which also tried to solve a problem of basically like, so a lot of legal documents get generated, a lot of text basically, right? So can I read the legal documents, extract clauses out of it, and so that somebody who is reviewing the legal documents can do it much faster than going through everything. One of the problems all these startups faced was that there were enough interns. So interns will do the job. So why do I need it? So right, like so. But the thing is, the same thing actually, like when the same solution was taken to enterprises, it actually clicked for them because in enterprises there are a lot less legal people, and so you may wonder like why legal and enterprises, right? Enterprises actually sign a lot of documents with vendors and suppliers. A lot of legal documents will be there. Or if you take any services company, they will have a legal like agreement with their customers, right? So and there also will be penalty clauses and things like that. So basically, they have to make sure that they actually understand that and actually like work in a way that so that they don't have to pay any penalty. I mean, like things like that, right? So they have to know when is the deadline for this, when is all those things, right? So and they will have thousands of documents. So somebody has to manage all these things, and so that is where actually like the understanding legal documents and culling out the important clauses and all those things were really useful. Financial, I think everybody will know, like basically like credit scoring and basically lending and all those places. Actually, people understand your bank statements and things like that to actually figure out like whether they can give you money or not give you money. That's another. So this is I already talked about it, and reviews actually. See, like I think in the previous talk, right? Like he was talking about you buy based on whether it's 4-star or 5-star and things like that, correct? But what if somebody can give you the same 4-star, 5-star, and all those things at a deeper level? Let's assume a mobile phone. If you take display is 4-star. Camera is 3-star, right? Like that's important because like it depends on what kind of phone you want to buy. So there are startups which are actually working on customer review analytics, basically at a deeper, like to provide deeper insights, so that it's much easier for people to actually buy the correct phone. Because and at the same time, actually, if you really see, a lot of product companies can use this. So I took that as an end-to-end use case where you take any brand or any product for that matter, right? So it always goes through various things, right? They get an idea, then actually do some research, strategy, marketing, promotion, lots of things. And it keeps going on whenever they actually like upgrade the product or yeah, okay. So all those things, right? So even in research, when they are doing research, they want to know what are the similar products which are there already in the market, what people are talking about it, how can we improve it so that our product wins better, right? Things like that. And also like people write lots of reviews. Today, there's no time to actually go through all those reviews, even as an end user or even for the brand manager. So brand manager wants to know how his product is doing, what needs to be improved. So there's a lot of NLP. Actually, like NLP can be used in so many different places, right? So this is another. So I just wanted to bring voice and NLP because for for a couple of reasons. There are a lot of NLP data is coming through voice nowadays because people want to talk. Like, okay, so people are doing more podcasts. People are actually like doing everything using voice, right? Voice control, like things like that. So some of the places where I have seen intelligent IVR, actually one of the most interesting things actually was podcast editing using text. You create a podcast, you want to make changes, I would have said, or like basically, right? How do I remove those things? So you just convert it to text, remove basically, it'll go away in the voice also. So things like that. Automotive command and control, lots of things are happening. These are some things which are more, doesn't belong to all these whatever categories I said. So there are guys who are trying to helping assistive, like basically people who are challenged, right? Sign language to text and vice versa, which is a very, very interesting use case. Describing a scene for a blind, right? These are text generation or voice generation things. Predictive police work to identify motives. That's one of the things which actually was really like cool use of NLP. Basically like the scene is described and everything, then basically what all happened, then actually they can actually try to predict what could be the motive, right? So things to that. I thought let me end with this. Lot of work has happened, but still there is a lot of work to be done. Because still actually like computers can't understand sarcasm and humor and all those things as good as we understand. So there's a lot of work. So I thought I'll end with this. So maybe you guys can actually work on these things and see how we can improve the, how you can make computers more like humans. Okay, thank you. I finished hopefully.
Thanks, Suri. One question, anybody?
So you mentioned NLP as a horizontal technology which has applications across multiple domains and a lot of opportunities. Yes. So how do you look at speech and or voice technology? Is it more towards a vertical technology or a horizontal one?
Okay. So okay, like if you're a startup, usually my suggestion is to actually take a couple of verticals and solve problems in that, and leave all the horizontal, like basically an API kind of things and all those things to all the big players like Google, and let them do solve those problems. Because it's tough to solve, needs a lot of money and effort. Basically, like if you can solve it for a particular vertical, it will be useful for people immediately, right? You can find customers. Otherwise, you have to find developers who are going to use your API and build solutions, which is a long-term this thing. So for startups, I would suggest build vertical solutions. Yeah.
Okay. Thanks a lot, Suri. A small moment of Thanksgiving.
Yeah, for the next 50 minutes slot, we are inviting Adarsha, who's a senior data scientist at Stackroot Labs, and she works on designing and developing machine learning-based solutions for Sunbird, an open source platform for which is being developed by EKStep, and she leads the team in building machine learning infrastructure and solving problems concerned with the learnings, such as content auto tagging and recommendation engines using NLP. Before that, she worked with R Plus Analytics and Deloitte India. She's MTech from DA IICT and BTech from Amrita School of Engineering. So, Adarsha. So she was here. Yeah. So during the breaks, there is a demo organized. So please use our time during the breaks to have a view, see what they are doing, share your thoughts, share your feedback, and see what you can. Yeah, Adarsha is here.
Am I audible? Yeah. Good morning. I will talk about the work that I'm currently doing, give a very broad overview in the limited time we have. I'll also talk about a specific use case where we use language models to create a learning opportunity for millions of students in the country. I work on an project Sunbird, which is an open source learning management systems being used by students and teachers and on a daily basis creating 100,000 telemetry events. Sunbird has had an ML component from the very beginning. Many of them architectured by Dr. Soma here, so you can prod him on it. The work that I'm presenting has been done over the years by multiple team members, including volunteers and interns. So school education in India is a multifaceted problem. We have 35 boards, 15 plus mediums, hundreds, thousands of textbook creation vendors, teachers with varied skill set, and assuming that content is the medium of delivering learning in a classroom, quality of the content is of utmost importance. How do you deliver quality content at this varied scale? Going by a problem, going by the approach that there could be one single solution to all this may not be the right approach. So we go via platform thinking, where a platform which would enable reuse of existing components, redefining problems, being able to quickly create solutions on the platform. So here I have a very broad architectural diagram of what Sunbird is. At its core, Sunbird consists of content, taxonomies based on which textbooks are created, question banks, analytical models, WordNet, all these forms the brain of Sunbird. Different functional modules use these digital spine of the Sunbird to create multiple data products, recommendation engines, content creation pipelines, consumption pipelines, registries, textbooks, badging, courses, and multiple other solution-specific applications. Users, including teachers, students, school authorities, boards, can access Sunbird via a portal, a mobile app, or numerous other plugins. An example is allowing students to scan a QR code printed on a textbook, which would take them to the relevant content being taught in the textbook. So this is a very broad overview of what Sunbird is. I will now go to a very specific problem that my team is working on, which is content reuse. As I already mentioned, assuming content is the medium of delivering learning in a classroom, quality of the content is of utmost importance. Every edtech company in the country thrives based on the quality of their content. So if a teacher creates a high quality content for his or her classroom, how can this be discovered by students across the country? Similarly, okay, why is this different from a movie or a video streaming app? Firstly, these content could be of any form, like this could be a PDF, an HTML, it could be videos, or it could be a YouTube link. It could be some third-party apps which allow teachers to create multimedia content. Secondly, these content are directly linked to textbooks or are derived from taxonomies. What I mean is, when a content is created for a textbook, every textbook in the country is created based on a limited set of taxonomies, so, or syllabuses. So this allows us to directly link a content to a taxonomy. We use this to, the core idea of our solution is based on this link. So for every physical textbook that is existing, we create a digital equivalent. This is similar to digital twins being created in other domains, such as already mentioned here, healthcare, or other industries where IoT is involved. For the digital textbook, which is created and is derived from a taxonomy, we can find equivalence between multiple taxonomies, and say a content is linked to one of the textbook, that becomes discoverable across all the textbooks in the country. This solves the problem of discovery across all mediums, boards, languages, and grades. So this is the implementation diagram. The solution has majorly three steps, and last step of suggesting content. The first step is text extraction. This is for a physical textbook, say a PDF, extracting the text is OCR. So we use third-party apps here. We have tried an ensemble of multiple services. The key points for us here is the OCR has to work for multiple languages. It has to work with multiple fonts. So every textbook publisher has their custom fonts. Then textbooks vary across grades. The way textbooks are printed vary across grades. So a class 10 maths textbook has more algebraic equations, whereas a class 3 environmental studies textbook would have diagrams and did you know sections, which does not fall under a specific topic. Also, in many of the textbooks, we see that it is the colors that distinguish between sections and subsections. So these are the problems that we require the text extraction module to take care of. Coming to DTB creation, once the text is extracted, the problem is not simply of, okay, I have a table of content, I have an extracted text, how do I map these, how do I segment the extracted text based on the TOC? So so this could be viewed in a very broad spectrum, a very broad overview as a topic modeling problem. Your TOC is your taxonomy, and your extracted text is the topics that you want to link to this taxonomy. We use multiple heuristic models, optimization techniques here to come up with a solution. So yeah, this is what I just talked about. So typically, textbook, table of content which gets printed in the beginning of the textbook is what we would be representing in the platform as. This might have a topic name, would have 5 to 10 words. Whereas when you add the text blob extracted from the textbook, this gives more contextual informations, which will allow us to give semantic representation to each topic in the textbook. Here I have a sample representation of the DTB. Once the text is extracted for each of the topic, we use, thanks to the publicly available deep learning models like BERT, TF-IDF. For Indian languages, we use fast text models, which we represent each of the topic. Also, every content that gets published on the platform goes through an auto-tagging pipeline, again, which handles multiple languages, multiple types of content, like I mentioned, like a YouTube content or a PDF. It goes through a content extraction from these for all Indian languages and tagging it to the taxonomy. So once you have a textbook which is represented in its semantic form, content which is again semantically understood by the system, and we could navigate between textbook across all the boards, across all languages. Once we create the digital textbook, mapping between one textbook to the other textbook uses generic distance mapping algorithms like EMD or cosine distance. That works fine for us at this stage. So everything that I have talked about, all these 4 modules, text extraction, DTB creation, digital textbook creation, textbook to textbook mapping, and linking content to the textbook. Each of this is not are all self-evolving models. It has to be, because once a DTB is created, a user or a curator who comes and looks at the textbook in the platform is going to come and give feedback. So there is a reinforcement learning happening there. Similarly, DTB to DTB mapping, textbook mapping is reviewed by subject matter experts, like who understands which textbook has to be mapped. Their feedback comes into the system. Also, the users, the end users who use the recommended content to a textbook is going to give a feedback in the UI saying, I like this content or not. So all these are self-evolving systems which has to incorporate reinforcement learning. Also, so the diagram here, the first one is a DAG that gets generated, directed, a cyclic graph that gets generated when we run this process. Again, these are, this process has to run for every textbook that gets generated on the platform. We have around 5,000 textbooks today. So every textbook has to run through this process. Every time a change in the algorithm happens, it has to go and rerun it for all the textbooks. Similarly, every module, like I said, a content, semantic understanding of a content tagging can be a separate microservice which can be reused across the platform. Or a DTB creation is a microservice which can be used by other modules in the platform. How do we enable this? So in Sunbird, we have a workbench, ML workbench, which we call DAGit, which allows us to represent ML algorithms as a DAG and rerun and deploy this in production very fast, and people to collaborate in working on this. I would like you to come to our stall and to get to know more about DAGit. That's it. Thank you. Any questions?
Any questions?
I'm sure you have been working also with library information systems across the world, taking through AI-driven discovery of books.
No, we are not. Right now, we are looking specifically in the Indian school education scenario.
Yes. So noble, thank you.
Yes. We are working on all Indian languages. So in the embedding space, we use different models for different Indian languages. But the DTB mapping that I mentioned works across all languages. And wherever we don't have tools, third-party tools available, we use translation.
So after this, we break for lunch, so there is enough time to interact, and they have their demo booth, again, where you can go and interact and ask more questions. So I'll request Ramesh to give our token of our appreciation. Thanks.
Thanks everyone, and thanks to IEEE organizers.
Okay, so with this, we will break for lunch. But as we told earlier, so there are these two booths out there. Kindly check out the solutions from these startups. Interact with them in terms of what the technology is. Some of those questions around different languages, etc. So kindly do take time out for the interaction. And the lunch is on the left side. The same place where we had the tea. Thank you. So we'll assemble back at 1. And we have an exciting session of speakers from Microsoft, Amazon, and a panel led by Juby from Intel. So look forward to your equally active participation in the afternoon.